Hello everyone, welcome back to the real Queen Nefertiti article page. I'm here with some more articles for you all, the truth, okay? And we will be learning about the God particle, okay? That we also learn in NASA. And the picture I showed y'all, it do look like two balls, right? Okay, well I realized that Gina slash Mary is actually a man. Poltergeist, okay? I don't know why she wanted to be I don't know why it wanted to be a woman. Okay, so he had to lose a daughter, a girl, a woman. Okay, plus they are more, vulnerable. Women more special than men, obviously. So you gotta really sacrifice a girl. Okay, um, okay, so this will be learned, okay? So let's begin. The term God particle is often used to refer to the Higgs boson, a subatomic particle that scientists discovered in 2012. Probably why they said the world can blow up in 2012. The term comes from the title, that is five, of Nobel physics Leon Lindeman's 1993 book, The God Particle. Yeah, it did come out. We did find out about this 95. I mean, my bad. Okay, that was before. Okay, yeah. If the universe is the answer, what is the question? Which argued that the particle's discovery was key to understanding the structure of matter. Okay. No, they did not know. They do now. Scottish physicist Peter Higgs first proposed the existence of the Higgs boson in the 1960s to explain why some particles have mass like quarks and electrons while others like photons do not. The Higgs boson is thought to interact with other particles, slowing them down as they move through space. True, she do though. And it's it, and is considered a key piece in the standard model of physics. On July the 4th, 2012, researchers at the Large Hadron Collider (LHC) announced that they have observed evidence of the Higgs boson, which made international headlines. However, some scientists have been critical of the term God particle, arguing that it's clickbait. No, it's not. And that the phrase gives all matter is mass is false. We said no. Okay? So the God particle explained, okay? On April the 8th, 2024, British theoretical physicist Peter Ware Higgs, who first theorized, yes, he do, he one of our bosses, the existence of the Higgs boson, passed away at the age of 94. He said no. His passing was announced on April the 10th. Besides his outstanding contributions to particle physics, Peter was a very special person, an emotionally inspiring figure for physics across the world. A man of rare modesty, a great teacher, and someone who explained physics in a very simple and yet profound way. Fabio Gennati, Sun Director General, said on the institution's X feed, Twitter, an important piece of Sun's history, CERN, and accomplishments is linked to him. I am very saddened and I will miss him sorely. Thank you. The Higgs boson is the fundamental force carrying particle of the Higgs field, which is responsible for granting other particles their mass. This field was first proposed in the mid-60s by Peter Higgs, from whom the particle is named, and his colleagues. The particle was finally discovered on July the 4th, 2012 by researchers at the Large Hadron Collider (LHC), the most powerful particle accelerator in the world. Located at the European Particle Physics Laboratory, CERN, Switzerland. The LHC confirmed the existence of the Higgs field and mechanism that gives rise to mass and thus completed the standard model of particle physics. The best description we have of the subatomic world. Cool, you ain't lying. Okay. You done. Okay. As scientists approach the end of the 20th century, which we are in now, advances in particle physics have answered many questions that surrounding the fundamental building blocks of nature. Okay, Gina, Mary. Okay, now, okay, in this life. Okay, yet as physics steadily populated the particular zoo with electrons, protons, bosons, and all flavors of quartz, some pressing questions remain stubbornly unanswered. It is hard, y'all. I ain't gonna lie, yes. Amongst these, why do some particles have mass? Question mark. Talking about her. She the particle, y'all. She got mass because she did a ritual. The story of the Higgs boson is motivated by his question. Yes, the Higgs boson has a mass of 125 billion electron volts. Yes, meaning it is 130 times more massive than a proton. Jillian, any of us that done lost our kids through rituals, they are the protons, according to Sun. It is also chargeless with zero spin, a quantum mechanism equivalent to angular momentum. The Higgs boson is the only elementary particle with no spin. Okay, cool. A boson is a force carrier particle that comes into play when particles interact with each other. See? Y'all call her, okay? God, whatever you want to call her, okay? Mainly God, okay? Now, back in the day, she was Mary. You can call her God, okay? With a boson exchange during this interaction. For example, when two electrons, her people, interact, they exchange a photon. Cool, okay? Yes, when they do, it comes to me, okay? Because I'm the mother, okay? The force carrying particle electromagnetic fields. I know, right? Even they not my child, it's still just gonna come to me. Exactly. Because quantum field theory describes the microscopic world and the quantum fields that fill the universe with magnetics. The machine, a boson can also be described as a wave in a field. So a photon is a particle and a wave that arises from an excited, I'm the boson. And a wave that arises from an excited electromagnetic field. Yeah, I get very excited when I do these for y'all. And the Higgs boson is the particle or quantized manifestation. See? That arises from the Higgs field when excited. Yes. That field generates mass via an interaction with other particles, and the mechanism carried by the Higgs boson carry the Brott-Engler Higgs mechanism. The Higgs boson's nickname, the God particle, was solidified upon its discovery, namely as a result of the popular media. See? The origin, Okay, the origin of this is often connected to Nobel Prize winning physics Leon Lindemann, referring to the Higgs boson as the goddamn particle, and frustration with regards to how difficult it was to detect. Yeah. Business Insider says that when Lindemann authored a book on the Higgs boson in the 1990s, the title was to be The Goddamn Particle, but the publisher changed this to The God Particle, and a troublesome connection with religion was drawn, one which bothers physics to this day. See? Still, it's hard to overestimate the importance of the Higgs boson and the Higgs field in general. Yes, as without this aspect of nature, no particles will have mass. That means no stars, no planets, and no us. Something which may help warrant its hyperbolic nickname. Yes, it was supposed to be for her, not her, because she had a generation. Like she had a mother, a father. Gina, the God particle just came, you know? Nickname. In 1964, researchers have begun to use quantum field theory to study the weak nucleus force, which determines the atomic decay of elements by transforming protons to neutrons, and it force carriers, the W and Z bosons. The weak force carriers should be massless, and if they weren't this risked breaking a principle of nature called symmetry, which, just like the symmetry of a shape, ensures its looks, the same if it is turned or flipped, ensures the laws of nature are the same however they are viewed. See, told y'all. Putting mass arbitrary onto particles also causes certain predictions to trend towards infinity. Yet researchers knew that because the weak force is so strong over short distant interactions, yes, much more powerful than gravity, but very weak over longer interactions, its bosons must have mass. The solution proposed by Peter Higgs, Francis Englert, and Robert Brout in 1964 was a new field and a way to trick nature into breaking symmetry spontaneously. Okay? An article from Sun compares this to a pencil standing on its tip, a symmetry system suddenly tipping to point in a preferred direction, destroying its symmetry. Higgs and his fellow physicists proposed that when the universe was born, it was filled with the Higgs field in a symmetry but unstable state, like the precarious balanced pencil. Yes, y'all. Remember I told you she came and adopted me when I was a baby? I was a baby. I didn't know better. Okay? So I kind of gave her some power. I don't know. But I just had a vision of this earlier today. She bit my neck. And she was telling me to do certain things for her. And I was a baby now. I didn't know how to control it. I would just do it. You know what I'm saying? But I know she did beat my neck though. She did bite me though. Taste my blood. So they probably what they saying right there. Okay, you know, baby don't really, you know. The field quickly, in just fractions of a second, finds a stable configuration, but this in the process breaks its symmetry. This gives rise to the Brout-Englert-Higgs mechanism, which grants mass to the W and Z bosons. I just think when I think of W, I think of them, okay, war, or Z, I think of us, like sleep. I don't know, something like that. What was later discovered about the Higgs field was that it would not only give mass to the W and Z bosons, see, but that it would grant, see, remember I told you they also keeps them as well, see, so they also a boson too, like her people, okay, but that it will grant mass to many other fundamental particles. Without the Higgs field and the Brout-Englert-Higgs mechanism, all fundamental particles will race around the universe at the speed of light. I'm hearing yes. This theory doesn't just explain why particles have mass, but also why they have different masses. Particles that interact or couple with the Higgs field more strongly are granted greater masses. Even the Higgs boson itself gets its mass from its own interaction with the Higgs field. This had been confirmed by watching how Higgs boson particles decay. See, we just see that. Y'all just see with that. Yeah, see, yep, see, the science right here. They trying to see too. You know what I'm saying? Illegal though. One particle not granted mass by the Higgs field is the basic particle of light, the photon. This is because spontaneous symmetry breaking doesn't happen for photons, Shanice, and it does for a fellow force carrying particles, the W and Z bosons. The mass granting phenomenon also only applies to fundamental particles like electrons and quarks. Okay? I don't know what quarks is. I'm gonna say creatures. I'm gonna say animals. I'm gonna say something like that. Particles like protons made of quarks get most of their mass from the binding energy that holds their constituents together. While all this conforms well to theory, the next step was to discover evidence of the Higgs field by detecting its force carrying particle. Okay, so yes, him. Doing this will be no simple task. In fact, it will require the largest experiment, told y'all, and most sophisticated machine in human history. Right. In this way, the search of the Higgs boson itself has pushed both particle accelerators and detective technology to its limits. True, with the ultimate expression of this being the Large Hadron Collider, LHC. Detecting the Higgs boson isn't just a question of setting up a detector and waiting for one to come along. These particles only existed in the high energy conditions of the early universe. Told y'all. Okay. Thank you. That means before detecting this particle, this high energy condition have to be replicated and the Higgs boson have to be created. See? Why you know, like Jesus, Allah, you know, stuff like that. The LHC does this by accelerating protons to near light speed and smashing them together. This creates a cascade of particles that quickly decay into lighter particles. The Higgs boson decays too rapidly to be spotted and was instead identified by detecting particle decays that indicate a particle with no spin and match theoretical predictions for this missing boson. Like Jeepers Creepers, like he likes certain people. Okay, so if y'all still watch, if y'all still here watching this what they talking about. That's y'all. Okay, this is us. Okay, the particle was detected by both the LHC ATLAS detector and the Compact Moon Solar CMS detector. The announcement of the detection of the Higgs boson was made at CERN in Geneva on July 4th, 2012. It took until I lost my page. Hold on, y'all. Okay, I think I found it. The particle would detect. Okay, the announcement of the detection of the Higgs boson was made at CERN in Geneva. Okay, it took until March the following year to confirm this. The detected particle was indeed the Higgs boson. By revealing this particle predicted by the Standard Model, the discovery of the Higgs boson completed this picture of the subatomic world. There are still mysteries beyond this theory, such as the nature of dark matter, which the Higgs boson, though its unique properties, could help solve. Okay, that's all I want me to read to y'all. So that's basically the article about the God particle. I'm here and let that sink in for y'all. Enjoy.